Humans are animals, yet we stand apart. We've walked on the moon, built digital networks, and split the atom. No other animal has achieved anything like this. We are the animal that learned to play God, reshaping the world to fit our desires. But for most of our existence, we were just another species in Africa, neither the strongest nor the fastest. Our secret wasn't in our bodies, but in our brains. The evolution of our extraordinary brain allowed us to cooperate flexibly in large numbers. Unlike bees or wolves, only Homo sapiens can unite thousands of strangers around shared stories and collective goals. This ability to believe in fictions like nations, money, and human rights sets us apart. These imagined realities let us build cities, empires, and global networks. We live in two worlds: the objective reality of rivers and trees, and the imagined reality of gods and corporations. Over time, our fictions have shaped the fate of the planet. How did we go from insignificant apes to planetary rulers? The answer lies in the power of our minds. This is the story of that transformation. Our story begins not with apes, but in Earth's ancient oceans, 4 billion years ago. Amidst chaos and volcanic fury, water was abundant, creating a primordial soup. Simple molecules, energized by lightning and sunlight, formed complex organic compounds. Eventually, a molecule emerged that could replicate itself, the ancestor of all life. Replication led to mutations. Some copies were better at surviving and making more copies. This was the dawn of natural selection. No plan, just chemistry and chance. Over millions of years, replicators grew more complex, developing membranes to protect their chemistry. These were the first cells, life's first breath, enclosed in fragile bubbles. From these humble beginnings, all life evolved. The journey from chemistry to biology was slow, but it set the stage for everything to come. Life's origin was a cosmic lottery, but replication and selection made it inevitable. The first cells marked the true beginning of evolution. From a single replicating molecule, the tree of life began to branch. Every living thing traces back to that ancient self-copying strand. The story of life had begun. For 2 billion years, life was simple. Single-celled organisms ruled the planet. Cyanobacteria invented photosynthesis, filling the air with oxygen and transforming Earth. Oxygen wiped out many early life forms, but some cells adapted, using it for energy. A pivotal moment. One cell engulfed another, forming a partnership, the origin of mitochondria. This gave rise to complex cells, or eukaryotes, with specialized compartments. For 1 billion years, these cells floated alone until they began to cooperate. Some stuck together, forming colonies. Soon, cells specialized, dividing labor. This was the birth of multicellular life. Working together, cells could grow larger and exploit new resources. The result? An explosion of diversity. Sponges, jellyfish, worms, and more. The oceans filled with complex creatures, all competing and evolving. Collaboration made new forms of life possible. The leap from single cells to multicellular organisms changed everything. Life became more intricate, more dangerous, and more creative. The stage was set for the conquest of new worlds. For billions of years, life was confined to water. Land was barren and hostile. The first pioneers were plants, evolving ways to retain water and stand upright. Soon, arthropods, millipedes, scorpions, insects followed, protected by exoskeletons. For vertebrates, the transition was harder. Lobe-finned fish with strong fleshy fins and primitive lungs ventured onto land. Fossils like Tiktaalik show the shift part fish, part walker. These early amphibians could walk, but still needed water to reproduce. The conquest of land was gradual, filled with challenges and innovation. Each adaptation opened new possibilities. Life was learning to master a new world. The land, once empty, was becoming alive. The next great leap was about to begin. Amphibians were limited by their need for water. Reptiles broke free with the amniotic egg, a self-contained nursery. Waterproof skin and powerful lungs let them conquer dry land. Dinosaurs dominated for 150 million years, from tiny hunters to giant sauropods. Meanwhile, small nocturnal mammals evolved in the shadows. Warm-blooded and furry, they could survive cold and night. They nurtured their young with milk, increasing survival. For millions of years, mammals were minor players. Then, 66 million years ago, an asteroid struck, causing mass extinction. Dinosaurs vanished. Mammals survived and flourished. The world was now open for mammalian innovation. Mammals diversified rapidly, filling every niche. The age of reptiles ended, the age of mammals began. From these survivors, new forms would emerge. The stage was set for the rise of primates. With dinosaurs gone, mammals diversified. Some returned to the sea, others took to the trees. Early primates thrived in the forest canopy, evolving grasping hands and feet for climbing. Vision became more important than smell. Eyes moved forward for depth perception. Navigating branches demanded bigger brains and complex coordination. Primates had fewer offspring, investing more in each one. Long childhoods fueled learning and social bonds. The primate order split. One group, the apes, lost their tails and developed new ways of moving. Apes gave rise to gibbons, orangutans, gorillas, chimpanzees, and us. Around 7 million years ago, our lineage split from chimpanzees. Our ancestor was an ape, adapted for life in the trees. The journey to humanity had begun. The next step would take us out of the forest and onto the savanna. Africa's forests shrank, replaced by open savannas. Our ape ancestors faced new challenges and began walking upright, bipedalism. Walking on two legs freed the hands and saved energy over long distances. Fossils like Lucy show this transition. Upright walkers, still skilled climbers. These early hominins were small-brained but successful. They foraged, climbed and survived, but made no tools or lasting impact. For millions of years they were clever apes, not yet human. The real revolution was still to come, not in our feet, but in our brains. The age of the big brain was about to begin. Evolution was preparing for its boldest experiment yet. The path to humanity was opening. 2.5 million years ago, a new genus appeared, Homo, the toolmaker. Shaped stones marked the dawn of technology and a leap in cognition. Making tools required planning, skill, and teaching, evidence of growing intelligence. Tools let our ancestors access meat and marrow, fueling bigger brains. A feedback loop began. Better tools, better food, bigger brains. Homo erectus emerged, taller, smarter, spreading out of Africa. They mastered fire, created hand axes, and taught skills across generations. The brain nearly doubled in size in 1 million years. Technology and cooperation set Homo apart from all other animals. The seeds of modern humanity were sown. The world was about to meet its most creative species. Homo sapiens evolved in Africa 300,000 years ago, one of several human species. For millennia, we were unremarkable until the cognitive revolution 70,000 years ago. Suddenly, sapiens created art, jewelry, and new tools. Most importantly, we developed language capable of sharing myths and fictions. This let us cooperate in huge numbers, building societies and armies. Shared beliefs in gods, nations, and laws united strangers. Sapiens spread out of Africa, outcompeting or absorbing other human species. Neanderthals, Denisovans, and others vanished. Only sapiens remained. By 12,000 years ago, we were the sole human species. From insignificant apes, we became planetary rulers. Our imagination and cooperation changed the world. The next revolution, agriculture, would transform our relationship with the planet. The story of humanity was just beginning.